Hi, this is Tom Kaler, and I'm going to give a little bit of an overview here on the foundations for generative collective intelligence. And this is really based on what amounts to almost 30 years of really trying to pursue the idea of how do we listen generously to a group of people. And the journey started out with applying that to consumer preferences, learning, working with Procter and Gamble and Lego and different companies like that. So while there's a lot of theory in here, this is a theory that is sort of attempt to be the learnings over the years and from these various activities and experiences. And so the audience for this and for the accompanying paper, uh, which is literally titled Foundations for Generative Collective Intelligence, is for people who are interested in the future of AI. Now, this is work that we've actually done in a commercial product over the last 10 years, but the new capabilities we're looking at is how do we take what all that learning is and put it into a technology infrastructure for collaborative learning for generative collective intelligence. So that's kind of the overall background. So what we're going to look at is how do we go from generative AI, which is learning from passive data, to generative collective intelligence, which is learns from collaborative data, the active dynamics of when we think together and bounce ideas off of each other. The second part is looking at AI as a way of doing dynamic learning and creating intelligence amplification, which is bullet two and three. We think about AI now as you apply it on data and it gives you a product. What we want to shift the focus in this discussion to, we are using it as a way to automatically acquire and retain the intelligence of a group of people or a group of people interacting with AI. And that is a very, very different problem, very different. And you should not see the AI. The AI is operating in the background. And this is often a misconception. And we've had this many times with CrowdSmart. Where's the AI? It's all around you and you're using it. And then the other perspective here is that the idea of we don't even, I'm not sure that the notion of AI is a great idea because, frankly, when you look at what works, most of the ideas have come out of either biology or information physics. Last year, Hopfield got the Nobel Prize in Physics for applying the Ising model of magnetism, of ferromagnetism, to how information is basically processed in the brain. And that is what led to deep learning. So I will make a proposal here, and everything in this presentation is going to be from a point of view of information physics. And that involves all information physics says really what we look at when we have a system, if we know the correlations, we can predict its dynamics using spectral analysis, resonance detection. And so when we look at transformer models, and there's in the longer math paper, I say that transformer models can really be modeled with the mathematics of particles in a mean field, an average field. And um, that is in fact the case. And therefore, it is what it is actually doing is discovering resonance modes of concepts that are extracted by passing these multi-headed correlation machines that are essentially detecting basically fact patterns forward and backward through documents and then learning what is the emergent resonant concepts within that document. And so that's basically how it works. We give it a bunch of books, text, etc. Unfortunately, in the way the current models were trained, they didn't do data provenance, but leave that alone a moment. We process it, and out the other side comes the top concept, and then a whole hierarchy of concepts underneath that. That's what it's learning. The eigenvalues or spectrum of concepts. You give text, that's what it spits out. And when we do prompting, what it's doing is taking the concepts in our prompt and seeing if it can match that. in an interesting way to a collection of concepts in its knowledge space where it knows what the various concepts are and as they are represented in the documentation in the text. Now, if we shift the context of this to people collaborating. And we know that every time we hit a hard problem, what do? We grab a smaller group of people and go off and do a meeting, a planning meeting, a design meeting. We used to call it design thinking. But the idea of we get together, we try to figure out together. Why do we get together? Because we think that through the interaction, we're going to learn something we couldn't learn on our own. This is very important. Now, where does the AI come into this? Well, if you just take all the notes and you had a transcript of everything said in that meeting, you could put it into an LLM and it would give you the resonant modes roughly. But what it would not tell you is the dynamics of that learning process. That instead of a meeting being over and you end up with a lot of yellow sticky notes and a vague memory, what we're suggesting is this technology will, when you're done that meeting, you'll have an absolute record of every idea, every thought, every interchange, every moment of interaction and the resonance modes of that group, knowing the history record of how that came into being. What you see in the middle here is actually something that we started doing about 8 years ago, which is when people are collaborating from a little bit of instrumentation, we can understand how people relate to each other's ideas and create a connection. Once we have this wheel and web of connections, uh, the Markov modeling and all that comes out of it. So we build this through a Bayesian learning process. So that's really what generative collective intelligence is about, is capturing that web and then figuring out what does it mean. So here we actually did this with NATO. 3,000 ideas coming out of 100 participants out of 31 countries trying to figure out how do we make better decisions together, considering that from 20 different angles. And over the course of an hour or two, I think actually the session might have been a couple or 3 hours, but it literally distilled out the half a dozen out of 3,000 plus ideas that resonated with the whole group. Now, is there value in that long tail? Of course there is. But if you, in the idea of it, continuous learning, we can understand how to move quickly through understanding collaborative action by this process. Again, the list ranking in the middle are the eigenmodes, or the resonance modes of the group's thinking. That graph on the right just basically is saying the size of the thing is how many people and how strongly they believed this concept. So what we can determine is the emergent alignment of a group around any topic. We can also determine the resonance modes of influence. Uh, we can keep track of who attracted the most links to their ideas. We can keep track of who was the most active in listening to others, and that's engage right. So these are spectral distributions, all three, that completely can characterize a group. The spectral ranking of the knowledge, spectral ranking of the generators of that knowledge, and a spectral ranking of the listening quality of that group. All very, very important if we're going to understand a movement of AI from individual or data to collaborative, social, or groups. Now, we can also then extract from that a model, a causal model, because remember, humans think in cause and effect. We don't think about, well, these bits line up and that might be a cat. We don't think that way. That's happening automatically in our sensory processing system. Our thinking is typically when we're in what Kahneman would call, thinking slow. We're thinking cause and effect. So thinking fast, yes, that perceptual thing. But where we solve problems, where we use our logic processing part of the brain and use our tacit knowledge, our experience, is when we think in cause and effect. Where we are now thinking, yes, I know that when these things happen, this is often derived from experience, culture, whatever. And that's really what we're learning from a group. Now we can produce from that an actual model of how an answer came to be. In the lower bottom here, it says 74% probability this is going to be a successful decision. It was an investment decision. The red dots are the factors that were considered. The outer next outer ring of dots are the themes or dominant concepts, and the outer ring are the individuals. And by the way, notice the dots are of different size, and that has to do with the peer-reviewed value. You get a higher ranking, weighting to your ideas if they're peer-reviewed, just like it is happens in science. So the other part of this is actually a knowledge builder. It extracts a probabilistic graphical model, which can be a twin of that knowledge or can be used, deployed. And so automated knowledge acquisition from collaborations can result in rich knowledge models of human thinking about some problem or some outcome, and then that can be deployed. So those are the basic ideas, and this is really what we've been doing. And so it creates a private knowledge model. Again, the private knowledge model is not just the vectors of that you would get from a text. These vectors have been weighted with the probabilities of relevance and a whole bunch of other things. We can annotate those vectors and create a much richer environment for generative outputs that do not hallucinate because they're only working on the vectors from that conversation. Now, where are we taking this? We're taking this into a experimental environment for collaborative learning. This is not a product. This is a laboratory for exploring. And I'll do another video talking about the details of this, but it's also looking at how do we turn this into a, um, a general API that's open and can be used in a variety of applications. So the shift now in our thinking at both Common Good AI and CrowdSmart is we want to understand the requirements, but we provide infrastructure technology in some open form that can then be integrated into solving problems. Now we're going to move into a little bit of what we go into some great detail in the paper. The for core learning loop is just like in the scientific process, peer review, but we do it at a microscopic level. Uh, I initially give my thoughts, my ideas, my prediction. I'm showed a sample of what other people think. I respond to that with some kind of thumbs up, thumbs down prioritization process, which gives a sense of how I correlate with other people's thinking. That results in a Markov model with resonance modes, and then the sampler can use that to repeat the learning process. So what we call it beta sampling, different from alpha in that alpha is about power, beta is about learning what is the emergent knowledge that may lead to some future outcomes. So what it's looking for, it doesn't share people's scores or what their decisions are. It says what is the causal reasoning that they're going through in thinking about their prediction. And so it explores, it challenges, it's basically at first trying to encourage divergent thinking. And of course, we have loads of tools for that. And then as the sample space is explored, it moves the group towards free energy minimization, joint confidence, shared reduced uncertainty. That's what it's looking to learn in the second part of that process. And so once it has a peer review, that peer review of 7 items turns into 49 A/B tests that could turn into a connectivity matrix that can then be used to generate a uh, correlation matrix that turns into a Markov model. That Markov model is now a memory of the state of that collaboration at that point in time. This is the core thing that supports adaptive learning. The beta learning engine is constantly updating. Every time somebody interacts with the system, it says, I know now where the group is going. And it uses that to try to learn the next step of where the group is going. So it's an adaptive learner that is constantly aggregating that into a memory, then using Bayesian sampling to learn the next step. So each participant's interaction changes the state or the interim knowledge of the system, and then the training mechanism is now seeing how we can evolve that. So this is not necessarily assuming that people won't change their minds in the interaction process. So the Markov model is a knowledge walker transversing the reasoning network, the proposition network, following citations and semantic connections, and creating that it then is learning using a method. Every time it learns the resonance modes, and it uses those resonance modes to guide the next step in the learning process. And what comes out? You get a distribution of the collective voice that reflects the priorities of the group, the thinking of the group. And that figure on the right shows how that evolves over time. What may be divergent, they move into some things that are supported by the group, some things that are not. And so it allows you to quickly, just like in the NATO example, to quickly learn. And of course, you do not ever want to just think you use this like you use a survey. Each bit of conversation leads to the next and the next and then the next. This is an infrastructure for collaborative learning. It is a way that we can evolve and build knowledge together, almost use the scientific learning process at scale to learn together what are solutions to our most challenging problems. Now, this does build a um, a visualizable model of the collective mind. And this is just showing uh, PCA reduction to 3 dimensions. Can use other techniques for doing exploring the hyperspace. But the reason I show this is that because we are learning the probabilities of relevance, uh, what ends up in the 3 dimensional space is a reasonably good representation of the top eigenmodes of the group. And so it's not necessarily as kind of arbitrary as you might think of just grabbing 3 dimensions out of 900 or 1,000 or 10,000. You've actually this is an annotated vectors that we've learned already, sort of what is at the top of the funnel for the collective mind. And so what we were able to do is discover new and emergent knowledge and new and emergent citation networks, how people are connected within groups. The reason Hilbert space is introduced here, and it's introduced as a conjecture, is so that we can use all of the apparatus, mathematics, of physics, of information physics, to do the analysis. It's an approximation, but I think it's a reasonably good approximation. And we can hopefully at some point, there's a theorem in the paper, not proven, but two of the key theorems in the paper that need a lot of further work is this one, as well as the notion that we remove the scaling factor. If you're doing Bayesian sampling, all of a sudden you do not have to worry about Brooks' law of communication complexity because it can listen in parallel. So listening to 1,000 people is about the same as listening to a group of 7 because it's able to manage that level of complexity compaction. So those are the big ideas. What does it mean for a user? It's not that crazy for the user. They're just going to get an invitation to come in, observe what's going on, people's discussion, use a research agent to learn about the topic, decide to join the conversation if they like. They can join by peer reviewing what other people are saying. They can explore, and we can show you more of how they can explore prior to going in and offering their own opinion. And then when they're offered to peer review, they can do various mechanisms. Here we show one of just hit it multiple times, thumbs up if you super agree with something. And then what the system does is translate that into a priority list using logarithmic smoothing. So this is a way to kind of create, and of course they then can look at the collective view. It's building this collective language model that's private to that particular deliberation. Um, we introduced a concept here prior to going into evaluation. This was brand new and different. It's this idea of let's create an area where we can kind of do a little bit more idea exchange. And it's sort of like jazz with cause and effect reasoning. And so here you're able to, for example, If you see something that you think is maybe not sure, it's suspicious in terms of its reasoning, you can flag it. Or if it's inappropriate, you can flag it as well. You can also dialogue with, reply to, ask questions. And it could, if it's an AI agent, the AI agent will answer you. If it's a human, the human will get an email and a notification to answer you. So there's a way, but notice we're trying to mask identity here. We're just showing the expertise of where it came from, and we're trying to do that. We can run it both ways, identity exposed or identity not exposed. But you get a sense here that this is an area where now you can kind of get knowledge sharing going on before going into giving your own viewpoint. This can be configured in a wide variety of ways depending on what your interests are. So the collaborations can be, think of this as sort of like an area of a new kind of Wikipedia where you can build models together and deliberate on different ideas like AI acts or climate or whatever else you may want to think about. Um, Collaboration network actually shows how these links are forming. We can talk about this more when I get into the product, but that's basically the idea here. We're really looking at generative collective intelligence as a way of doing group cognitive intelligence where we're learning together. Where does this have applicability? Well, obviously, if we're going to do things like move from in deliberative democracy or city planning or things like that, where we understand what is how do people perceive the problem? What is the inner workings that's going to evolve to collaborative action? You can see where this is a very powerful tool in multiple stages in a learning community. You can also see this being applied to corporate alignment, change management, where you really want to understand, say, hey, we have got to change our fundamental business model. How do we operate a process where we discover where everyone is with this and then help migrate to where we want to go? That's a process of minds, ideas colliding and possibilities of discovery, of epiphanal breakthroughs. That's what you get with generative collective intelligence that you can never get by simply turning a model on the data you generate in a meeting or turning a model on the papers you publish. That's good, but it's a contributor to this kind of thinking. This is the next stage of where I personally believe AI needs to go. And the purpose of getting this out there is to try to bring in new thinking, new minds around how do we take this forward. And this, from the existing project's point of view, is being built out for the NATO project on how do we help uh, red decision teams make decisions with AI agents in highly critical environments. It's also available for the Loyal Agents project, where we look with Consumer Reports, is how do we create very trusted environments for humans, trusting agents? We can measure that interaction and create ways of learning how to build agents that integrate well, have a cognitive bridge with how humans think. Thank you very much. And if you have any questions, you can send me an email at tom@crowdsmart.ai. Thank you.